Today I want to look at solving equations with variables on both sides. We worked on this a little bit in class yesterday, but I noticed a lot of you were having a hard time, so I want to make sure that this is something that I don't just skim over, because you're going to need this over and over again when you move on to geometry next year. And even the rest of this year. So we're going to spend a little bit more time on this, and the objective is to solve equations that have variables on both sides of the equal signs. And we want to be able to identify equations that have that are identities or have no solution. So we're still in that same standard where we're creating equations in one variable. Okay, so it says, what is the solution of 5x plus 2 equals 2x plus 14? I know in the past that you did the circles and squares, and so to be consistent, we'll stay with that. So I'm going to circle all of my things that have variables, and I'm going to put squares around the things that do not. Now notice, when I did this, I included the sign in my circle and square. That way I don't make a mistake here. So then I'm going to also put a line down through the equal sign, because I want you to remember these properties of equalities that I keep stressing to you guys this year. Whatever I do on one side, I have to do to the other side of the equation. So I know in the past that you were taught to move both circles to one side, the squares to the other side, and that's still what we're going to do. And you did it horizontally. I still like the vertical alignment, but you can do it whichever way you want. Just realize that I'm not moving the 5x. It's staying there, so I'm not changing the sign. And in the past, you were told to move the 2x to the other side of the equal sign and change the sign. Why do we do that? Because the property of equality, I'm using the subtraction property of equality. I need to get rid of this whole 2x from this side and move it to the other side. And when I do that, in order to get rid of it, I'm subtracting 2x. If I subtract 2x from this side, notice I have to subtract 2x from that side. Okay, then on the other side, I still have this positive 14. I didn't move it. I just dropped it down. Drop down my positive 14, and I'm taking this positive 2 and I'm moving it across the line. So you've been told, if you cross the line, change the sign. That is correct. Why do I change the sign? Because it's a positive 2, and I want to get rid of this whole positive 2 from this side. So to get rid of plus 2, I'm going to subtract 2. The subtraction property of equality tells me if I subtract 2 from this side, that I must also subtract 2 from this side. And I know this sounds redundant. I know it's a little bit boring. I hope you're listening to what I'm saying, though, because you need to understand why you're doing what you're doing. It will make your life a lot easier later on. It'll make your life a lot easier right now if you understand why you're doing it. So 5x, take away 2x. Now I can simplify. These are like terms. They both have x in them. So 5 take away 2 is 3. I'm going to keep my x. These are like terms. 14 take away 2 is 12. Now at this point, what I want to do is get the x all by itself. So I'm separating this 3 from this x. So the way that I would do that, since it's multiplication, to undo the multiplication, I'm going to divide. The division property of equality says if I divide this side by 3, I must divide this side by 3. 3 divided by 3 is 1. 1 times x is just x. So x equals 4. And that is the solution. Plug it back in and check. 5 times 4 plus 2 should be equal to 2 times 4 plus 14. 5 times 4 is 20. 20 plus 2 is 22. 2 times 4 is 8. 8 plus 14 is 22. So they are equivalent. They equal the same thing. So x is equal to 4 is the solution. At this point, I would like for you to pause the video. Go ahead and try this problem on your own. What is the solution of 7k plus 2 equal to 4k minus 10? Well, circles and squares. Circle the variables, put squares around the constants. Once again, notice I include that negative sign there in my square. So I'm going to keep the 7k over here, did not change it, didn't move anything, so it's still a positive 7k. But I'm going to move this 4k over to the other side of the equal sign. So when I move it across the equal sign, it becomes a negative. To get rid of it, I subtract 4k from both sides. So it's gone from this side. I subtracted 4k. Over here, I'm going to drop my negative 10 straight down. Keep that negative with it. Drop the negative 10 down, and I'm going to get rid of this positive 2 from this side of the equal sign. I want to put it over on this side of the equal sign. So to get rid of it, I would have to subtract 2. If I subtract 2 from this side of the equal sign, I must subtract 2 from this side of the equal sign. So 7k take away 4k is 3k. Negative 10 minus 2 is negative 12. If I divide both sides by 3, k is equal to negative 4. We can plug it back in and check. 7 times negative 4 plus 2 should be equal to 4 times negative 4 minus 10. 7 times negative 4 is a negative 28, plus 2 is a negative 26. Over here, negative 4 times a positive 4 is a negative 16, minus 10 is, in fact, negative 26. So we know that negative 4 is, in fact, a solution. When you're doing these problems, there's no reason why you should ever get it wrong, because you can plug it back in and check. Even if you have to work it out a couple times, look for your mistake, find out what you did wrong. You should know when you turn your paper in if you did it correctly or if you did it incorrectly. Okay, I like the word problems. I used to hate them when I was your age, and I know that you guys don't like them a lot of times now, but I like the word problems because it helps me realize when this type of problem could be used in a real-world scenario. It says an office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office. He spent $650. It says it's reducing the electric bill from $112 to $88. In how many months will the copier pay for itself? Now, this is a great thing to be able to figure out because, I'll just give you an example. My husband and I have been thinking about getting those energy panels. I can't think of what they're called, but they soak up the solar panels. They soak up the sun, and then they convert that energy into energy that then can run your electricity through your house, and it makes your electric bill cheaper. However, the cost of those is really, really high. So I have not yet bought them, but my husband and I have been trying to figure it out. You know, is it going to be beneficial for us in the long run? You know, we're pretty young. We plan on living at this house for the next, well, probably till we die, so hopefully that's a long time. So, you know, these kind of problems are beneficial. How long would it take the solar panels to pay for themselves? You know, if it's going to be cheaper on my electric bill. And that's exactly the kind of problem that this is. It's asking us to figure out how much money you're going to be saving, or how many months you're going to have to use that copier before it pays for itself. Because, you know, if it's going to be a really, really long time, chances are the copier is going to quit working before it pays for itself, if it's going to be like 20 years before it ever pays for itself. So these are the kind of things that you want to know so you can present this material to your superior at your job and convince them that, yes, you really need this copier. So we need to figure out how many months will the copier pay for itself. So what I would like to do right off the bat is figure out how much money is it saving me each month. Well, if it was originally $112 and now my electric bill is $88, I'm saving a total of, what would that be, 12 and 12 is 24. I'm saving $24 per month. So $24 each month is how much I'm saving. So I want to know how many months will it take of me saving $24 to make $650. So I would write an equation. $650 is equal to $24 times the number of months. So if I'm saving $24 each month, how many months will it take me to get to $650? So if I divide that out, 650 divided by 24 gives me some really weird number. It's like 27 point, I just typed it in the calculator, 0.083 repeating, and the 3 just keeps on going. That's the number of months. Well, do we calculate months in 0.83? No. So in terms of this problem, what would make sense? How many months would it take? 27 months isn't going to be enough because it's more than 27. So it would take 28 months for the copier to pay for itself. So that would be, a little over 2 years. The copier is probably not going to break down in 2 years. I know the high school here had the same copier. They just got a new one last year, but they had the same copier from back when I was a student here in 2006. So 10 years, it's only going to take 2 months to pay for itself. Then for those next 8 years, they're going to be saving $24 each month. So for 8 years, saving $24 a month, that's going to be beneficial to the school's budget to, buy the new copier in the long run. It's a little more expensive up front, but it will save money over the long term. I think I skipped a problem. I sure did. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, so 1.25 hours, or an hour and 15 minutes. But it takes 8 hours to learn the new software. So how many web pages would the designer have to make in order to save time using the new software? So once again, I would encourage you to pause the video and try this problem on your own. See what you can come up with, and then come back and check your answer. So right now it takes him 1.5 hours to make a web page. The new software takes 8 hours to learn. So we know he's going to have to spend 8 hours learning it. But then he's going to be making web pages the designer could complete each web page in 1.25 hours. So at this point, it's going to take him 1.25 hours to complete. So we want to know, when are those two values going to be equal? How many web pages is it going to take him to make, because he's spending an hour 0.25 for each web page. So, you can use the H, but really, I don't like that variable. I'm going to change it to P, because I feel like H, you're going to think we're talking about the hours here. We're not talking about the hours. We're talking about how many hours it takes him to make a page. So it's an hour and a half per page. Over here, it's an hour 0.25 per web page. Okay, so now we want to know, how many pages is he going to end up making before this starts saving him time? So I'm going to get my like terms together. I've got the P here, the P here. So I'm going to subtract 1.25 P from both sides of my equation. I like to think of this in money, because 50 cents subtract 25 cents is obviously 25 cents. Makes it a little bit easier than saying 0.5 minus 0.25, if you think in terms of money. Okay, so 0.25 equals the 8 hours that it's going to take him to learn the software. So now what I need to do is get the P all by itself. So I'm going to divide both sides by 0.25. Or what I could do is times both sides. This is the same as 1/4 P. So to get rid of the fraction, I would times both sides by 4. That's going to be a whole lot easier to do mentally than divide by 0.25. So we know that it is 32. So he's going to have to make 32 pages before it's going to be beneficial for him to spend 8 hours taking that course. So if he's only going to be doing this for a couple more days, being the web designer, he only has a few more pages to make on the website, then, it's not going to be beneficial for him to waste 8 hours of his time to learn a new program just to make a few more pages. But if he's going to be doing this for the rest of his life, he's going to make, 32 pages in no time at all. So it would be beneficial for him to spend 8 hours to learn something that's going to cut down the amount of time that it takes him to make a page by 15 minutes. So that answers that problem. Okay, let's look at solving some equations with grouping symbols. Anytime I see grouping symbols, I automatically think distribute. So looking at this, grouping symbols, let's see if I do need to distribute. I've got 2 times some stuff in parentheses, 3 times some stuff in parentheses, or in those grouping symbols. So I am going to have to distribute. That would be the very first step. I want to multiply both things in the parentheses by the 2. So 2 times 5x is 10x. 2 times a negative 1 is negative 2. Bring down my equal sign. Now I want to distribute on this side. 3 times x is 3x. 3 times the positive 11 is a positive 33. Now we can begin to do our circles and squares. So I can never remember which one goes with which. I guess it doesn't really matter as long as we're consistent here. So I've got a 10x and a negative 2 on this side, and I've got a 3x and a positive 33 on this side. I've got to get those red circles together on one side and those black boxes together on the other side. So how would I get rid of this negative 2? I would add 2. Whatever I do on one side, I've got to do to the other. Notice I lined it up under the other circle. So I've got my black box still, my 10x, and I've got my equal sign. This is gone, so I don't need to bring it down, but I need to bring down my 3x. And then I'm just going to go ahead and combine these over here. What is 33 plus 2? Well, it's going to be a positive 35. At this point, I realize that I need to get this box over here with this box. So in order to do that, it's a positive 3x. To get rid of it, I'm going to subtract 3x. I'm not trying to separate them at this point. I want to move this whole box over. So that's why I'm subtracting 3x from both sides. 10x, take away 3x is 7x. Bring down my equals. Bring down my 35. Now I'm trying to separate the two. So this is multiplication. To separate them, I need to undo it by dividing. Undo the multiplication by division. Whatever I do on one side, I have to do it on the other. So x is equal to 35 divided by 7, which is 5. Okay, I want you to go ahead and try. Oh, no, I didn't give you a problem to try. I'm sorry. So what I want you to do now is see if you can separate these down here into the appropriate category. Are they identities or do they have no solutions? Well, in order to be able to do that, we need to know what is an identity. An equation that is true for every possible value of the variable is an identity. And there's no solution when no value will make the equation true. So let's look at these. If I plug in some different numbers here, is anything ever going to make this true? If I plug in 2, this side gives me 2 plus 1 is 3. This side gives me 2 plus 2 is 4. Is 3 ever going to equal 4? No. The way that I know right off the top of my head that this is going to be a no solution is because I've got an x on both sides, and on this side it's being added by 1 or increased by 1, and this side 2 is being added to it. So no matter what value I put in, there's no value that I can add 1 to, and it's going to be equal if I add 2 to it as well. So this is going to be no solution. Here, obviously this is an identity. Any number I plug in, 2 plus 1 is 3. 2 plus 1 is 3. 3 is going to equal 3. If I plug in a million and 1 is going to be equal to 1,000,001 every time. So this is an identity. Looking at this one, is there any number that I can plug in for x and get the same value on this side if I multiply it by x? It's not going to happen. So this is no solution. This one is going to be an identity because any value I plug in, if I plug in 1, I get 54 equals 54. If I plug in 2, I get 54 times 2 is equal to 54 times 2. So every value is going to work. So let's look at a little bit more complicated versions. We want to know what is the solution of the equation. So go ahead and pause the video and try to solve this. Okay, I realize that there are grouping symbols, so I need to distribute. This is 2 times the group 5x plus 6. So I'm just going to come over here and drop this straight down because I'm not going to be doing anything with it. Now here I'll go ahead and distribute. 2 times 5x is 10x, and 2 times 6 is 12. Now we can do our circles and squares. I want to get my 10x's together and my 12's together. So I'm going to subtract 10x from this side to get it over here with this 10x. Well, if I subtract 10x from 10x, I get nothing. So I have 12 equals 12. Really, I didn't even need to go that far because I can see right here, 10x plus 12 equals 10x plus 12. These are the same thing on both sides of the equal sign. So this is an identity. Any value that I plug in for x will make this equation true. Okay, let's try this one. What is the solution of 9m minus 4 equals negative 3m plus 5 plus 12m? Okay, we can do our circles and squares again. Notice I'm including the symbol, the plus and the minus, in my squares so I don't get confused. Okay, I'm going to rewrite it. Move that 3m over, so it's going to be a positive 3m. Move that 12m over, so it's a minus 12m. I'll keep my equal sign. I've got a positive 5, and then I'm going to move that negative 4 over, so it becomes a positive 4. So 9m plus 3m is 12m. 12m minus 12m is 0m, or just 0. And 5 plus 4 is 9. Does 0 equal 9? Obviously not. They're not equal. Therefore, there is no solution to this problem. Okay, what I want you to do is complete the worksheet that the teacher has for you. Please do your best, show your work, and check your answers. There's no reason why you should miss any of these because you can check your answers.